to cover 2 programming languages because we are doing diploma. And one of the language that we said we need to look at Pascal, and then we have C programming. But because now I had explained the course outline, before we had some hitch on network issues, so I think now we can be able to continue from the introduction. So the first thing that we are supposed to understand, maybe I can share this. We are supposed to look at definition of terms, and I will use PowerPoint maybe to define that. So we need to look at definition of terms, and the definition, the first term that we are supposed to define is what you call a program. What is a program? And what we understand about a program, we understand a program as an instruction. An instruction that instructs a computer. But when it is instructing a computer, it's supposed to instruct a computer looking at various objectives. So there are some objectives that you have to look at, and these are objectives that has already been set by the user. And the user wants to meet some aspect of communication, and this aspect of communication is through a given program. And that program has to be coded through what you call a programming language. So we understand that having a program, it is coded through a given programming language. So sometimes we need to understand what is programming language and what is programming. Where we understand that programming language is a language that is used in coding a specific program. And you can code this specific program through various techniques, and that's why we need to look at these techniques. And one of the techniques that we look at is what you call the structured technique. We can look at unstructured technique. We can look at object-oriented technique or object-oriented technology. Maybe we need to look at event-driven technique, given that now these are the classifications of this program. So in some cases in programming, we call them, these are paradigms. These are paradigms of programming, or these are techniques of programming, or these are approaches of programming. So in this case, when you come up with a certain programming language, where now, in our case, we look at structured, we have C, and we have Pascal programming as 2 aspects of programming that we are supposed to have. So in this case, we understand that this programming language has to be coded. And when you code that, and that is what you call programming. That is what you call writing a program. So the moment you are writing this program, now the first question that you are supposed to ask yourself, which language am I supposed to use in order to write this program? So we have said we can use structured. So when I use event-driven, maybe I can use what you call Visual Basic, VB. Either you can use Visual Basic.net, or you can use VB 6.0, or any other programming languages that we have currently. If it is OP, object-oriented programming, now in this case we can use Java programming language. Maybe we can use others that nowadays you can call it Python programming language. But in most cases, we'll be able to use C++ languages. So remember now, we are using C++ as an object-oriented programming, but here we are using this. So for unstructured, this is when you change whatever has been coded in another format that the user will not be able to understand. So that way of writing a program is what you call programming. But now, who writes this program? So the person who writes this program is what you call a programmer, who is supposed to write this program. So a programmer is a person who writes program. But the moment you're writing this, I want to clearly talk about the structured way of writing program. And in a way of structured, the way we write program in a structured manner is where we say we have a step-by-step approach. We have a step-by-step approach of writing a program. So in this case, we are talking about procedural. We are talking about procedural way of writing a program. So it must start from somewhere, then it ends somewhere. So in this case, we have a start, and we must now have an end somewhere. After you write, you start. So you cannot have an end without a start. You cannot end if you have not started. So you cannot start if you don't have some variables that you have to declare on that. So that is what you are supposed to look at as a definition of a structured programming. So you'll be able to look at different ways of understanding this, where we can understand that structured programming is always categorized into various categories. One is top-down, and the next one is what you call the bottom-up. Top-down and the bottom-up approach. So those are just few explanations. I think we can go directly to these notes that I have here, and that's why we need to understand the structured programming. So we have said this is a way of organizing and coding computer program in which a hierarchy of modules are used. So in this case, if I can use Paint, so in this case, we are saying if this program is starting at this point, so this is start. So it is supposed to move up to where we can have end. Just take an example. You wake up in the morning, then after waking up in the morning, you do something. And there's something that you are supposed to do. Maybe we can say we wake up. Then after waking up, you bathe, maybe you take breakfast. Then after taking breakfast, then after that, maybe you go to school. So in this case, we are having a sequence of operation. So we are having a sequence of operation. And this sequence of operation that we are having, we cannot wake up and go to school, then we come and bathe, then we take breakfast, or we take breakfast, then we come and bathe. So there is that organization that you have to follow in this way of communication. So that is when you're talking about structured, where now the user is able now to look at now interpretation of the program from top to bottom. So that's why we are saying each having a single entry and a single exit point, and is in which control is passed downward through the structure without unconditional branches to higher level of structure. So if you look at this structure that we have here, even if it is not clear, we don't have branches. We are not saying that now when you take tea or you take breakfast, go to school or sleep. So those are not branches. So those are branches, but they are not branches here. So you find that we are moving from top to bottom and completing whatever we are supposed to complete. And that's why in this case, we'll be looking at now programming language that you can use. And one of the programming language that you can use as a structure, we use C and what you call the Pascal programming language. Those are the basic programming language that you can see, that you can use in this group. The next one is computer hardware, and I think this one is not new to you because the hardware is something that is physical, something that you can see. When you talk about a hard drive, when you talk about a table, when you talk about a computer that you are using, when you talk about a mouse that you are using, those are all hardwares that we have. And why do we need them? We need them to allow the user to fill some information. So we must use some softwares that are supposed to be used in order to create some program.
You are currently the only person in this conference.
And if you look at the execution that you are supposed to have within this, you find that now a software is a set of instructions, yes, but these are programs. So these are programs that has some documentation. Like now, if we look at now, we go to a supermarket, there is a system that has been created there. Mostly the system that we are using here as an e-learning platform, it has already been created for you to use as a platform for e-learning. So in that case, we are using it as a software. When you use an operating system is still used as a software, of which we call it a system software. Because I don't want to go in a certain area of ICT where we are supposed to understand that software is always classified into two, where we have system software. So this is software, and this is system software. Then here we have what you call the application softwares or application programs. But when you come to the system software, this is where we always look at the operating system here. And then we can have what you call the system services. System services. And system services are the ones that are now allowing the user to use an operating system. But when you come to this application, you can either have programming softwares, general application program, and what you call the specific program. I don't want to go beyond that. And that's why we are trying to explain it here, because we have to classify where is the operating system. So we can say the operating system is a software, a system software, being a software. Where we have said a software is a program or a dedicated program that has documentation that can be used by the user to accomplish a certain job within a given time. When you look at application, mostly we are looking at word applications, we are looking at programming languages that we use. Mostly we are using C programming languages. So all these are now application programs because they assist you to apply some knowledge that you can maybe use to code. So I think I have explained this, and I have said a program is a set of instructions that control or instruct a computer on what to do. And when you talk about a computer, we are talking about the computer hardware to carry out a given task. Then we have said we have programming language, and I have said programming language, there is a language that can be used to present a certain objective. So that's why we are saying it's a set of symbols and rules that govern the rules that are employed in construction of a computer program. Now, there are these terms that we need to understand here: syntax, semantics. I think we have understood what is a programmer, where we have said there is a person who is trained to code or to write some program. So the moment you'll be writing a program, you become a programmer. But a programmer in writing which language? So that is a specific language that you can be able to deal with. Either you're using structured, you're using event-driven, or any other category of a language that we have. Then when you look at syntax, these are rules of language that govern in which one, symbols. Like now I can say, maybe I'm coming up with a construction, or I'm coming up with a construct of what has to be used. Maybe I'm looking at a point where maybe this is a strategy of doing something. Let me use that word, a strategy of doing something. And this one, I will be applying it the moment you'll be writing a program, because I will be referring it to a specific point where we need to write a syntax for a given data that we have, or a format. We can call it a format. And that's why we are saying these are symbols or expressions or words. And mostly you can use either a presentation of different wordings in programming language, of which in programming language you don't even care the language that you're using. Sometimes even if you're using a broken language, it doesn't matter at that point. What matters is what am I supposed to communicate at that point. So in this case, maybe we can be able to understand that the moment you are talking about this programming language, we have said we will be specifically dealing with these. And that's why I have said one of the types of techniques that you can be able to work with in this aspect, we'll be able to talk about structured, unstructured, object-oriented programming, event-driven programming, and many other that we have within the code. So in this case, let us try to understand about the first language that we are having here. And we have said types of structured programming language that we are supposed to have. One of them we have Pascal. And I want to read these instructions or the histories of this programming language. But if you look at this first language, was written by a person called Blaise Pascal. So as the name suggests, and mostly it was written for mathematic purposes. That's why we still use it today, but it is not in the market because it's a very old language, because it is inflexible, and because we don't have tools to allow it to be written. Sometimes we have some issues. But one of the languages that is mostly used in writing an operating system is what you call C. And that's why we are saying is a high level. And when you talk about a high level language, we are saying is a language that can be interpreted from source code to object code. So it's very easy for you to interpret that program. And in this case, what we have is a Unix operating system. And Unix operating system is one of the category of an operating system, because we always understand that there are various categories of operating system. And one category of an operating system that we are supposed to have, because I don't want to maybe for you to contradict yourself with the types operating system and categories. So categories, we have Windows operating systems, we have a Unix operating system, then we have mobile operating system, where we have different kind of operating system. We have DOS operating system and many others that we have. But that is why we are saying here, this C programming language, it was mostly used for writing programs, which was invented in 1970s. And this is a language that is still used up to now for academic purposes, because for our case, we will be using C programming language. The other structured programming language, we have Fortran. Fortran means formula translation. Formula translation, mostly used for scientific purposes, for construction purposes, which can tell a user on how to calculate mathematical expressions that are supposed to be used. So remember, it is still the one that can be used to create bridges, such projects as design of bridges and airplane structure. So if you look at Fortran, was designed for scientific engineers and has dominated as this field, which mostly it was designed for bridges and airplane structures. So we use these languages to design an airplane structure in a way that you can be able to understand. The other one is Common Business Oriented Language, which is mostly used for business purposes. We have Logo programming languages. Mostly this is like a Lisp programming language, which is mostly used for interactivity, where the users can be able to interact with the objects, etc. And others, we have Lisp, etc. Now, I think up to that point, maybe we can be able to understand a few terms, of which we will be able to define other terms as we progress. Remember, there are others like variables. What are variables? And why do we need to use a variable? Maybe, so a variable is a memory location. But in this case, we will be able to understand it clearly the moment we will be writing cons. And that is the point where I will be able to define most of the terms that you have not defined at that point. So for now, maybe we can first of all, maybe listen to your concerns, maybe what I have explained up to that point, before we go to the histories of programming. So is there any question up to that point? And maybe what you have written, or maybe if I'm too fast, you can tell me I'm too fast, I can change that. Okay, I have seen you saying that my voice was breaking. Okay, I'm sorry for that. I think now it is clear. So are we together? Are we together? So I think we can go to histories. Can we go to history? So can you hear me now? Can you hear me? Okay. If there is an echo, please, it is on your side. Before, when you're not talking with the mic, please, you should switch it off. So switch your mic off, please. Switch your mic off, Esther. That's why there is an echo. Just click on this, you mute if you're not using a mic. That's why we have an echo on your side. Oh, you join with listen only, but I think you can see your mic somewhere. The problem is we don't have somewhere we can mute.
You are currently the only person in this conference. You are currently the only person in this conference.
So just a minute, there is an issue with the share file. Let me try to check on it.
You are currently the only person in this conference.
So I think maybe we can proceed, but before we proceed, there is some issues on sharing. That's why I'm trying to rectify on this. Okay, so I think it is now clear. Okay. So what I'm saying, I'm sorry for that. I'm sorry for that. So what I was saying, for now, we can look at now the history of programming. And each and every language has its own history. And in our case, because now we are not looking at histories of C programming, we are looking at programming for all languages. And in our case, I can use PowerPoint. We always classify histories of programming in two parts. One, we classify them as low-level languages, and the next one as what you call the high-level languages. In these low-level languages, we always say that we have two main categories. We have two categories. One of them is what we have, what you call the machine language. And the next one is what you call the assembly language. We have what you call the assembly language. So these two languages are termed as a low-level language because they are interpreted on one way, not two ways. Meaning, for the machine language, it uses binary coding. And when you talk about binary coding, we are looking at 0, maybe 1, 0, 1, 0, 1, 1, 1, 0, 1. So these numbers, they have their own interpretation. But when I understand about the human way of understanding languages, we understand languages as numbers, maybe as characters. But for this case, we are understanding them as zeros and ones. Meaning, this is now a given number within the presentation, but we can interpret it in a way that the user will be able now to understand, because there is a code that the user will not understand. So we find that when you're using the machine language, it is easier to understand, and it is easier to follow, and it uses less coding, because now we are only using this, so it is easier to interpret. But now, since we need to look at the user intervention and the user way of writing programs, that's why we went to what you call the assembly language. And within the assembly language, we look at now, there is a language that uses mnemonics. It uses mnemonics. Mnemonics are abbreviations. These are abbreviations. Like now I'm using the word English, I use ENG. So the user will be able to understand, and now the computer cannot understand. So within this language, we had to use what you call the assembler. So assembler is used to, it is a translator, which interprets, or interpreter, which interprets languages from low-level language to high-level language, or interpret in a manner that the user will be able to understand, or the computer will be able to understand. That's why we have three main types of translators. One, we have compiler. Then we have assembler. Then the next one, we have what you call interpreter. We have interpreter. So in our case, for compiler, we'll be using compiler the moment we'll be looking at the high-level languages. For an interpreter, the same case, because now we are looking at executing one statement after another. If I have the first statement, maybe I have two statements. I execute one statement at a time, interpreting it. So error is more in interpreter than when you have the compiler, because in a compiler, you combine everything together, or all programs together, and then you can be able to execute them at once. So instead of executing one after the other, you execute them at the same time. So in this case, you are able now to understand the program. The computer is able to understand the program, and here it's still understandable, but here we are only looking at now, it's very hard for a user, for a computer to understand. So you need an assembler to assemble the languages together, written in mnemonics, and then interpret them in a manner that the user will be able to understand. So that's why we are saying high level refers to a machine language and assembly language. I think I have explained that. But in a high level, this is where we have COBOL, Fortran, Basic, etc. And in high-level languages, we are now interpreting the code in a manner that the user will be able to understand from low-level to a high-level language, and from high-level language to a low-level. So we are looking at two ways of interpretation. And when you're looking at these two ways of interpretation, we are able now to understand that the users are able now to understand the code. So that's why we are saying low-level languages, machine, digital computer represent across data interpretation instruction as binary numbers. So I think for that I have explained, because we are using zeros and ones. And I will not explain on how we can be able to convert these numbers, because I know in ICT, you will be able to convert those in numbering system. And that is the point where we'll be able to understand why are we talking about zeros and ones in that interpretation. And that's why we are saying it has some advantage. One, translation was fast. That is very fast, because it's a language that a computer can understand. That is okay. So interpretation is very easy. The program could directly address and control internal circuitry, meaning that these programs were more effective in hardware usage and control. That is very correct, because if you look at this interpretation we are looking at now, it is more effective to the hardware that we are using, because they have already been coded in that. But there are some disadvantages. I think maybe at your own time, maybe you can look at these advantages. And one that you can be able to look at, it's not efficient. This program, when you write program in machine language, it's very cumbersome, time consuming, and many others that you are having. And that's why we need to look at the assembly language. And I think I have talked about assembly language. Are we improving speed? Are we less cumbersome? So you find that the disadvantages that you find on this language becomes now the advantages. So much easier to run compared to machine language. Very easy. Because in this language, only users are computers are understanding, which is termed as a first generation. And for this one, computers and users can be able to understand, which is termed as a second generation. So in this case, all users and computers can understand. But for the first one, it is only the computer which were able to understand, which is very hard. So that's why they went to high-level languages, and it was able to solve the problems that were in the low-level languages. And one problem that we are able to solve is portability. And I think that is the advantage that, yes, it is the advantage that has been given here, because we are looking at now, there's a program that you can change. It's not a must that you say we have programmed it in computer A, then we cannot use it in computer B. We can still use it. It is around. It uses procedures. It uses procedural way, structured way of writing a program. That's why we have said most of these programming languages that we have there, one of them is BASIC, the other is Fortran, COBOL, etc., C programming, Pascal programming languages. Those languages that are currently still in the market, that we can still use when you are coding. And that's why, if you look at this, we have classifications. And most of these classifications that we have procedural languages and non-procedural languages. And when you talk about procedural language, this is step by step. I think it is clearly explained. One of them is Fortran, Pascal, and BASIC. But non-procedural languages is when you don't follow a certain order. So they allow the program to find the result without having to specify the detailed procedure needed to achieve the result. So I only need results. I don't even require maybe how you calculated a certain program and to come up with that language in that. And most of these consist of query languages like MS Access database that we have, application generators like SPSS.
You are currently the only person in this conference.
Report generators like SPSS. So all these are languages that you can be able to understand within the interpretation, where sometimes you have to look at a program you have written in a procedural way. It is easy to understand. It's not like the one that you have written in an procedural language. So the next thing that we have is object-oriented programming. And object-oriented programming mostly are programming languages that uses objects. They use object. So these are the main languages that we have. One, we have low-level languages and high-level languages. In a high-level languages, we have said we have procedural and non-procedural. While we have said we still have operating system like we have programming language like object-oriented programming. Then if you look at the 5th generation, these are the languages that mimics the human intervention. Like one of them that we have talked about is Lisp, Lisp. That's a language that mimics the human intervention. And that's why we are saying build on the premises that a problem can be solved and an application built to solve it by problem constraints to the program. So we are looking at the programs that are currently in the market, like now Python, R language, and many other languages that we have in the market. Those are 5th generations, and they mimic that. So those are few generations that we have within these programming languages, but maybe we can understand these programming paradigms. And I remember when we are talking about these programming paradigms, I remember I said another name that we can call them techniques. We can call them techniques. We can still call them approaches. We can still call them methods of programming. So all these are names that we can call these paradigms, because paradigms are a way to classify a programming language according to the style of computer programming. Now, if you are using C, it has its own style. If you are using C++, it has its own style. If you are using Java, it has its own style. So all these are now categorized as paradigms. Are categorized as paradigms. And in this case, are classified as paradigms. And most of these paradigms that we have, one of them is unstructured paradigms. And I want to emphasize mostly on unstructured paradigms because these are languages that the user will never understand the structure. These are the languages that moves up and down.
You are currently the only person in this conference.
They allows you to change from one point to another. They allows you to move from one point to another. And that's why we are saying they uses what you call a go-to statement. Like now, if I can use a simple example here, and this example maybe I use, I introduce a label, and this I say I write a code. Maybe I write a code like that. Maybe we can use this presentation. Then I say go to E, go to E, go to E. Then after that, I write another code. I write another code, etc. Then I write another code, etc. So if you look at this presentation, we are looking at an aspect where I was starting my program from this point systematically. But when I enclosed go to statement, I went back to E. So if this statement is not satisfied, we cannot move to this statement that we have already written after go to statement. So this part of a program that we have here is what you call unstructured program, where the user will never understand the language, the structure, where the user will never understand the flow of the execution and many other things that we always have within the programming. But we can solve that using what you call the structured paradigm. And the structured paradigm, I think I have explained this, is when you use a step-by-step approach. Meaning, if there is a code, we don't need to use goto. We don't need to use goto. If I have started from this statement, let me go to the second one. Let me go to the third one. Let me go to the fourth, up to the fifth one, until my program ends. Within this, now we are saying we can be able to look at now, program execution has already been solved in a matter of what you call a structured way. Object-oriented, it uses object. And one of the programs that we can use here, I have said it's C++. We have what you call C++, and we can use Java. C++ and Java, programming language, and many others, because it's not only these that are categorized as object-oriented programming, where we have real object, and each is viewed as a separate entities having their own state, which is modified only by built-in procedure. So you can come here, maybe you come up with an object here. This object you code. When you code it, like now if you look at your mobile phone, I have a button, start button. Maybe if I press an M-Pesa button, that is an event-driven. That is an object-driven. It is an object-driven because that is an object. That is an icon which is coded as an object within the interpretation. So in this case, we understand that most of the languages that we use, the best languages that you can use in the market, if you are developing a good system, mobile applications, we can use what you call the object-oriented programming languages. So do you have any question up to that point? Do you have any question? Any question? Do you have any question? Any question up to that point? Please. So can you hear me still? Any question? So can you hear me? Do you have any question? Any question? Okay, so I think I can continue. Let me continue maybe, because I have seen you have understood. And I don't want maybe to go further, because I wanted us maybe to understand these terms, so that next time maybe we can start on program coding. So if you look at what we are supposed to look at, we have looked at structured and unstructured programming languages as a paradigm or a paradigm. But now we still have looked at the object-oriented, but we have visual programming. Visual programming languages, they are the ones that allows the user to create programs by manipulating programs or element graphically. And maybe we can look at most of the programming languages that we have currently that are able to allow you to do that. You can use Stera. I think this is a very new program we can use Julia programming language. You can use Julia programming language. And these are the current programming languages that we have that are mostly used for modeling. So we can say these are the languages that are mostly used for modeling purposes. For modeling purposes. And that's why we are saying graphical symbols used in each element of syntax or secondary notation. I can still add another one that we have, which allows that. It's called Visio programming language. All these are languages that are currently being used in the market that are mostly used for these purposes. And they assist the user in one way or the other. Either maybe coming up with drawings, coming up with diagrams, models, etc. Because when you're coming up with a model, you cannot use C programming language. You cannot use C++ programming language. We have a specific language that you have to use. The next one is internet languages, and I think this is not new to you because most of the languages that we use, one, we can use what you call HTML, hypertext markup language. We can use cascading style sheet, CSS. Maybe we can use PHP, personal homepage. We can use Perl, etc. Maybe we can use JavaScript as a language. So all these are now languages that can be used to classify an internet-based language. And I think we have explained this. The most common language used for that, which are mostly used for coding web development programs. So anytime you want to code a web development, maybe a website, you want to come up with a website, you can use HTML, CSS, PHP, where these languages, they must work together. Maybe you can use Perl, you can use JavaScript, and many other that we have, because there are many. And we'll be able to create a program that can be used in web development programs. Then the other things that we need to understand within programming before we start programming is what you call the hardware and software consideration. The hardware and software consideration. I want you to avoid all these, to avoid all these, and just understand one thing. We need an IDE, independent development editors. And the editor that you can use, mostly for C language, we'll be using an editor called Dev++. We can use what you call code block. We can use what you call Visual Studio, and many other. It is not a must you have a computer. You can use your phone. You download a source code, which you can be using in your mobile phone, and you install it. You just install the application on your mobile phone. So these are the editors that you are supposed to use in C, and we still use them in C++ language. But when you're using Pascal, we use GNU. We use GNU compiler. So for these ones, each and every one has its own compiler. So you have a C compiler, C++ compiler, Pascal compiler. But now, what comes within these, what differentiates these is now the editors that you are supposed to use in coding. And that one I'll leave to that point until the time that you start coding. That is the time that you'll be able to understand this. And the requirements, you require processing power that is automatically. You require memory, computer with memory. You require a computer with storage, maybe peripheral, that is input-output devices. And then maybe we can say the memory, because now I can emphasize on this, we can look at a memory that is not less than 1 GB. So we need to use a memory that is more than 1 GB, at least 1 GB, so that we can have a better programming cons because of speed, because of the efficiency in the execution. Because the moment you are coding and you take time in coding, it is not efficient. Automatically, you become tired because of that programming language. Then when you look at the software requirements, I think I have explained some software requirement. You still require operating system. You cannot work without an operating system. And I think on Monday we had a class on operating system, but you did not attend, but I recorded. Have you seen that recording? Have you seen the recording for the last class for operating system? Yes, Akinyi, can you respond to that, please? Did you see those notes? Have you seen the video? So I have seen a question that you have typed. Will you post the notes on the wall, on the portal? Let me use portal. Yes, I have already posted them. Those notes are on your portal. But have you seen the operating system notes on your portal? The video that I recorded, because you are not there, there are some students who are supposed to be there, but they are not there. Are you doing operating system? Are we together? It's good to respond so that maybe if there are some issues, maybe we can rectify. Please. Have you seen those notes for operating system? Have you seen them? So I think we can proceed. So most of these requirements that you require.
You are currently the only person in this conference.
So I think now you can answer that question. Maybe you can answer as we continue. So these are you need an operating system. And I want you to maybe look at the current operating system that we have. Maybe you have Linux, we have Windows operating systems, and others. We still require drivers. So when you use an editor, like I'm using Dev++, either I'm using Codeblock, is it accessible in your hardware? So if it is not accessible, you require some API driver. And that is application interfaces that are supposed to be used for that hardware devices that we have. So those are the requirements that we need when you are coding. Those are the requirements that you need when you are coding. And that will assist us now to introduce programming. And before we start introducing programming, we need to understand about program development and design. So I think I will explain this. I have not posted this note for programming development and design, but I'll be able to post them as the second lesson. And maybe we will be able to have a recap next time because I will explain today. Then after that, we start maybe the third topic that we are supposed to have. So for now, maybe I want to receive some questions from you. I still need to receive some comments, and maybe you clarify whether you can understand what we are talking about. So let me repeat what I have said. I have said, have you understood what we have covered up to that point? Maybe introduction part. Because if you look at the notes, this is the second topic. And I want to explain the second topic. Then next time we can have a recap of this topic. Or maybe we can start this topic next time. But have you understood the first topic? This is introduction, definition of terms, requirement, paradigms that are mostly used in programming. Have you understood? Have you understood? Yes? Please respond so that we can continue. So we can proceed. So we can proceed. Let me take at least 10 minutes to explain this topic. I have said this topic is not on your portal. I will post it today so that you can read the notes, please. And make sure that you read all the notes that I have posted, because in this topic we require some things that we need to understand here. There are many things that we need to understand. If you can see, it is a very long topic where we need to understand how we can be able to write a program, where we should be able to start writing a program, and the purpose of writing this program. So in this case, if I can start maybe so that we can have a clarification on it. So we are looking at program development and design. And if you look at program development, we are looking at now coding. If you look at the design, we are now coming up with what you call a blueprint. So it is the same case that we can say we are coming up with what you call a blueprint. And when you say we are coming up with a blueprint, it's a structure that can be used in programming. Where we say the software development is a process of computer programming, so coding. And if you look at the definition that has already been provided here, we are saying it is a computer programming, documenting, testing, and debugging. Testing, we are looking at whether this program is okay. If it is not okay, maybe we can do some rectifications. And this change that we can be able to make within a program is removing errors. But how will you be able to remove these errors? So there are various tools that you can use in order to remove these errors, and we will be able to look at them after we understand about this program development and design. Design is a process by which an agent creates a specification of software artifacts. Like now, just look at a person who is building a house. Before you build a house, you require an architect. So an architect always come up with an architecture. And this blueprint is now a presentation of how the building will be looking like. So whoever is now building the house will be able now to follow the fact or the fact finds that are already been created by the architect. So in this case, if I say maybe I'm looking at a building and this building that I have, I need to start from this point. Then this is a building that I have. And within this building, I need to separate it into this. Then I separate this into two. Then I separate this. So here we have a door, maybe if I'm using a house. This one is another house room. This is another room. So in this case, maybe we have this room. And here maybe we have a corridor. Let's say we have a corridor. And in here, we have maybe a kitchen. Maybe this is a table. This becomes a structure. And this is the one that we are calling it a what? A program design. So this is a design. But for our case, we are looking at now, what are the things that I need so that I can be able to come up with a structure. So that's why we are saying software artifact intended to accomplish goal using a set of primitive components and subject to constraints. So we are looking at now, it's like presentation of this. So if somebody comes, it's very easy now to build this house. So you know that you'll be having how many rooms? 1, 2, 3, 4, 5. So one room is a kitchen, the other one is a table room, the other one is maybe 3 bedrooms. So maybe rooms that you have, maybe this one can be a toilet or maybe any other thing that you have. So you look at that aspect of coding. So in this case, that's why we are saying we are using program design. You come up with a fact that can bring to a specific objective. And for this case, that's why we need to understand the steps in coming up with this design. If you are coming up with this design, what are the requirements? From this point up to this, you need to do a research. The rand, maybe your rand is very small. If it is too small, you cannot come up with a very big house. That is not good. So if it is small, you come up with with respect to the size of your shamba that you have or garden that you have. Then if you look at maybe, you look at now, you're building a house for one person. So you cannot build a house with these rooms. That is a waste. It's better you have a very big table room than having this. So those are requirements. And that's why we are saying we need to look at program development life cycle. One, you need to come up with objective. My objective is to do what? Right now, if I come now to programming, if you go to ZTech University, you find that there is a problem with the system. And this system is about registration. So that is now an objective. You start from there. When you start from there, you can now design the problem. So before we design the problem, you can do what you call analysis. You can do what you call analysis. And when you do the analysis, this is when you are correcting. We are correcting all variables required. All variables required. So this is variable X, this is variable M, this is variable Z. So if I combine them, I will be able to come up with a design. So in this case, when you come up with this design, let's say we have already completed the analysis in objectives. Now you can come up with a design. And the moment you are coming up with a design, you need to look at what you call the design tools. Which are those design tools? One of the design tools that you can use is what you call the pseudocode. Then you can use the flowchart. When you use the pseudocode, this is an English-like statement. It's like we say, wake up, bathe, go to school. Those are 3 statements, one after the other. So that is a pseudocode. So you can say start. Maybe we have a start. Maybe wake up, bathe, go to school. Then you end. So that is an English like. It's something that is structured in an English way of writing a program. Then after that, we can look at the flowchart. A flowchart is a grammatical presentation of element. And that is now why we need to understand a flowchart somewhere here, which we can be able to clarify on how it can be used. So this is now a flowchart. We have said to use a pseudocode in designing a program. And when you design using a flowchart, now you use these symbols. How will you present it? How will you present it? So there is a start. So use this symbol. There is a what are you doing? There is an output. After now doing that, what are the results? Like now, if you have a program to add two numbers, maybe we can have a program to add two numbers. And two numbers. So how can you present that using a flowchart? So in this case, we need to use output, decision. If I have two decisions, maybe there is two alternatives, one alternative A, or maybe I tell you, come to school if you have a pen. Suppose I don't have a pen, where will I go? So I stay at home. So the determinant is either having a pen or not. Then you can have connector. So in this case, we can say maybe we are having insert, maybe we insert using this, and maybe we can have a circle. Then we can have a process here. So this is a flow. So this arrow means it's a flow. Then maybe we say we input, maybe input two variables. Then after inputting two variables, now you can get an output. So from this, maybe you can get an output. I don't know whether there is that symbol somewhere. If there is no symbol like that, maybe we can use our own interpretation. I think there is no shape like that. Okay, there is. So we use shape like that. Then after that, maybe we can do what? Maybe we can end in this, where this program has already ended. So we are saying we have step-by-step approach of doing these things. And if you have this step-by-step approach of doing that, we use what you call a flow. So in program design, it assists you in coming up with a given program that you can be able to code within the respective time. Then after you design that, remember here, you require a designer. You require a designer. So remember there is a programmer and designer. So the designer is the one that is doing that. A person who is building a house or who is coming up with that structure
You are currently the only person in this conference.
Cannot design. So you need to have a designer and you need to have what you call a person who can program. So this is where now you write a program. After you write a program, always make sure that at the end, you save that program as maybe file name.c. File name.c. Remember, this is a C programming language, and I think next time I will be able to install that application. Then we start from scratch on how we can be able to write a C program using that. Then after that, you compile. Compiling means consolidating all the statements together, then you execute. So we are looking at whether these programs has been converted from source code to object code. And then maybe we can run the execution. When you run that is now the time that you get this program has errors or not. And that is why you test the errors. When you test the errors, there are various tools that you can use in testing the errors. One of them, you can use isolation. And I think they have already, you can use integration testing, regression testing. You can use unit testing. You can use beta testing, system testing, stress testing, performance testing. All these are testing that you can be able to go through them when you are now coding, so that now you can be able to rectify that.
In this conference.
And then you debug the program. When debugging means involve finding the errors and fixing those errors. Then you can be able to look at the last point, which is now maintaining the program. So when you create a system in a given organization, you must make sure that this system is running up to the time that it's supposed to be implemented. So in this case, you'll be able to understand this system is able to work for a given duration of time. Is it supposed to be 3 years? Because most of the systems are able to work for 3 years. And if they can be able to work for 3 years, now after that, what are you supposed to do? Because there is change in technology, there is change in generation, there is change in the system structure and the policies that are supposed to be used in a given organization. So you have to make sure that you are keeping on change for every time that you are using the system and for every time that you are moving the execution for this. So I think up to that point, we are able now to understand that you cannot write a program from nowhere. You first of all come up with objective, you analyze that objective, you design that objective, then after that you write that program, and then you compile. So when I'm expecting you, when you're writing these programs, you'll be able to follow these steps that we have already tackled here, because you cannot run a program when you have not coded or when you have not designed. You cannot test a program if you have not coded. You cannot maintain the program which is not there. So you have to look at those aspects that you have. All these are types and why we should have these programs. So automatically we understand that when you're using structured programming, it becomes easier for you to use it because of various aspects that you can be able to use in that. So there are many testing that we have here. So I would like maybe at your own free time, maybe you read and you read on this top-down approach. Remember we said a structured programming is always composed of a top-down approach, moving from the main program to down. So first of all, you understand the program. Then after understanding the program, then you go to some programs. But bottom up is when you are moving from bottom up. So you first of all come up with some structure. It's like now you're using your M-Pesa and there is M-Shwari. If M-Pesa is not functioning, M-Shwari might be functioning. So it is not affecting other. Each and every application has its own way of interpreting it. If you look at modular programming, so this top-down is always classified as modular programming. So modular is a way of coding the programs in module, one module at a time, one statement at a time. So you don't have to code them at the same time. So you have like this program, you code this first, you code read book record. Then when you combine these two, you form this. This we are calling input. When you code this, you combine this process. When you code this, you combine this. But now, because you have these three, you have to combine these three so that you can come up with the main program. So these are now modules. Module 1, Module 2, Module 3, Module 4, Module 5, Module 6, Module 7, up till you have the main program. And that's why we are saying, if you're using modular programming, this code can be reused, because if this module is not functioning, I can change this module without affecting this. And I will not affect the execution of other programs that we have. Testing is easier because I can test one module at a time. But the problem is when you have monolithic programming, where these programs are not organized. We don't follow any structural way. And this is a self-contained, which is not independent. An independent program that it's very long, which is not composed of these. It's like one program that is very large. Sometimes we call it a spaghetti program. So we don't have these modules. It's one program without these modules that we are having here. So just read about these differentiation. You'll be able to do a recap on that. And then after that, we'll be able to understand. So we have others like tables, decision tables, but I will not tackle them because most of them that we always use is pseudocode and flowcharts that we can use. So I think up to that point, you are able now to understand the structure or the program development cycle that we should be able to use in that. So that now, maybe next time I can have a recap. Then after that, maybe we go to the next topic that is called topic number 3, which is called program structure. And in program structure, you'll be able to understand many things here This is where now programming comes in, and that's where we'll be able to start programming. So up to that, do you have any issue? Have you understood the second topic, of which I will be able to repeat it next time? I was doing a fresh up of a fresh down of all the topics that you'll be able to cover at that time. Do you have any question? Any question? So I'm waiting for any question, please.
You are currently the only person in this conference.
Is there any question, please? I'm waiting for your question before we go to the. Okay, I have seen your concern here. I don't know where is the issue, but I can see on my side I don't have any issue. Maybe you can look at maybe your side. Maybe there are some problem in connection. Maybe. So what I want us to do, as you respond to what you are responding, I want us to go to the platform where we will have some questions that we are supposed to do, and where we are supposed to have a question, and those questions you are supposed to do them because they are graded. Remember, for each and every class that you attend, you are supposed to grade a student on the capability of understanding the concept. So please, you can go to your portal. I will set a question after 5 minutes. So give me 5 minutes so that I can be able to set those questions, please. Can we move to the question room?
You are currently the only person in this conference.
So can we proceed? Do you have any question? So can we move to the chat room? So you give me 5 minutes to set the question. So I think we can move to the quiz room so that we can answer that question, those questions, please.